Today we are going to learn about the most important function, in my opinion, in the entirety of JavaScript, reduce. So how does reduce work? Let's start with the simplest example. So let's go 3, 2.1, 5, and 8. We want to find the sum of all of the numbers in this array. And so we're going to take the array, we're going to reduce it. The first parameter, as you can see, is callback function. And this callback function here, let me make this a little bigger. And this callback function is going to accept two parameters. It's going to be the total and then the given number. And all we're going to do for each iteration is we're going to return the total plus the given number. But that still leaves us with one question. What is total going to start at? For the first loop, we're trying to add total and number. We know that number is going to be 3, and then it's going to be 2.1, and then 5, and then 8. But what is total? Well, that's what the second parameter is for, the initial value. And so we're going to set the initial value of total to 0. And so when we output this, we get 18.1. And so, of course, 8 plus 5 plus 2.1 plus 3 is 18.1. What if we wanted to change that to multiplication? Well, anytime you multiply by 0, it'd be 0. But what if we wanted to start it at 2 instead? Well, then we get 504. So it's going to say 2 times 3 times 2.1, so 2 times 3, and then 6 times 2.1, and then whatever that is, times 5, and then that number times 8. And we'll get 504. Point a ton of zeros and then 6. So that's all reduce is doing, is it's just getting the total and then continuing and comparing that total against the next number. But I said this was the most powerful function in JavaScript. So obviously there's got to be more to it, right? Well, check this out. Let's say we have 3, 4, 10, 50, or 60. And then we want to get some of the values, or more specifically, we want to filter the values and only return the values if they are less than 10. So normally what we can do with filters, we can just do number, and then we can do number is less than 10, and then we'll get 3 and 4, right? But with reduce, we can do the same thing. Right? So we can just do the given item or number, and then we can do number, and then we can do the accumulator or the values or the list of values. I like list better. And so we're going to do the same thing that filter does, but we're going to do it with reduce. And so we're going to return an array, and so our initial value, our starting value, is going to be an array. And so then all we're going to do is we're going to say, okay, if the given number is less than 10, then we're going to return the list of numbers, but also the number itself. Otherwise, we're just going to return the list. And voila, we got the same thing that filter got. Now, the only other thing we'd want to do is it looks like filter automatically sorts it. Or, my bad, looks like it doesn't sort it. It just adds the number in after the list. So there we go. We have the exact same output. But again, like, this is cool, but it still doesn't justify it as being the most powerful function in JavaScript. So what if I told you we could just continue down this pattern and replace just about every array function in JavaScript using reduce? So let's start with sum. Let's go on to sum. So let's do 3, 4, 10, and 50. Sum is going to return a Boolean, and it's just going to say, okay, number or item in the array, and then a condition that should return true or false. And this condition is going to be, is the number less than 50? Are some of the numbers in this array less than 50? Whoop. And of course, we need to make that an arrow, just like that. And the answer is true. Some of the numbers in this array are less than 50. Now, if we went back here and we removed that, we'll still get true. And if we just add 50 and 100 and 5,000, well, none of those numbers are less than 50, so we get false. So how do we do this with reduce? So we're going to do the same thing. We're going to say reduce. And then we're going to add the check or condition. And we're just going to say the initial value is false. And then we're going to say if the condition equals true, return the condition. Otherwise, return, and then we need to make this the number. Otherwise, return the number is less than 50. And just to clean this up a bit, I'm going to knock this to the next line, and then this to the next line, and then that to the preceding line. So this time, instead of starting with an array or a number, we're starting with a Boolean. And we're just saying, okay, if one of these numbers is less than 50, return true. And it works. And of course, if we were to get rid of the first 3 numbers in our array and make that like 50 and 350, we get false. So far, using reduce, we've replaced map, we've replaced filter, we've replaced sum. Now, we could also go on to replace every. And I'm not going to do that because that's very similar to every. But all every is it's the same thing as sum. But if we go like this, and we do every number, and then number is less than 50, instead of seeing if some of the numbers are less than 50, it's going to confirm all of the numbers are less than 50. So since we have 50 in there, it's going to be false. We remove 50, it returns true. Of course, we could replicate this with reduce very, very easily. So what about join? What if we had, like, I don't know, a truck, a car, and some people, just some random things. We wanted to join it using a dash. Truck, car, people. So how would we do that in reduce? Well, again, very simply. We just say, okay, here's going to be our text. Here's going to be each word. And all we want to do is say the given text and then the given word, right? And then all we're going to do is go right here. The one thing I'm noticing is that our dash is going to show on the first one, and we don't want that. So here's what we can do. The callback function inside of reduce accepts more parameters. The first being index, and the last being the original array, right? We don't need the last, we just need the index. So we're going to say if index equals 0, just return the word, otherwise return text-word. And so with that set up, if we rerun this function, it will now act exactly how the original join method does. So far we've got map, filter, every, sum, and join. What about concat? Whenever you do 1, 2, 3, and then concat or concatenate with hey world Mars or so, I don't know. Well, we get that. Well, how would we do that with reduce? Well, check this out. If we do 1, 2, 3, and then we want to reduce, and then all we need to do is we're just going to pass in each array as an element and to reduce. Just like that. And we can actually combine any number of arrays doing this. And so we're just going to say total or list, and then we're going to say array. All we're going to do is we're going to do list and then array. Just like that. And of course, our starting value will be an empty array. And voila. Now, what's cool about this is, unlike concat, or maybe concat does, I don't know, but we can add as many arrays as we want. And we just keep adding them here. And it will combine all of them. Whoop. As long as we add that last bracket. And there we go. So we now have the ability to add together as many arrays as we want. So that is join, and that is concat. But let's get into a few more examples. So right here I have a few people I've created, Sarah and Tim, and then we're going to create one more, and we'll call him, I don't know, Lynn. We'll say name is Lynn, email is lynn@example.com, and the ID will be 55. So what if we want to group people by their name? So we want to say like people.lynn and then get Lynn, or people.sarah and get Sarah. So check this out. We're going to say let people equal, and then we're going to say Sarah, Tim, Lynn, dot reduce, and then we're going to say the person object, or I guess we can just go people, it's inside an array. We're going to say people, person. And then all we're going to do is we're going to make our initial value an object, and then we're going to return an object where we're going to deconstruct our current people object, and then we're simply going to say the key is going to be the person's name, and then we're just going to pass in the person. Now this is not going to work. This is not going to work. And I'll show you why. It says we're missing our colon. Well, what's really going on is whenever you have an object that you're returning from a shorthand function, for whatever reason, you need to wrap it in parentheses. And so once we wrap it, now we have people. So now if we want to do people.lynn, we get Lynn. People.sarah, we get Sarah. People.tim, we get Tim. And if we want all our people, people, Lynn, Tim, Sarah. Just like that. More than that, what if we want to get, and let's clear this out real quick. What if we want to get just the names of the people? So let names equal that, and all we're going to do is we're going to say person.name, and then we're just going to pass in the names. Person.name, just like that. We'll make our initial value an array, of course. No. Oh no, that is so tragic. That is so tragic. I hate when that happens. Okay. The names equal that, and then we're going to say reduce names name equals person. Deconstruct the current names we have, get the person dot name, and then start with an array. Now if we do names, we have Sarah, Tim, Lynn. Of course, we could keep going on and doing that if we wanted all the emails, we do person email, emails, and then emails. And then we have all of the emails. So what if we have a list of arrays, right? Or list of arrays, just to keep it consistent. And then some of those arrays have elements, and some of those arrays have lists of arrays. Sub1 and then sub2, right? And then it has another nested array, sub3 and then sub4. And then it also just might have some elements, 1, 2, 3, just like that. How do we go about, and let's make this list and list so we know what we're working with. How do we go about flattening this array? So let's take our list of arrays, and let's of course use reduce. And we're going to say flattened is going to be what we're going to use for our accumulator. And then we're going to say the item, flattened item. And so first what we want to do is we want to return an array. So we're going to make that our initial value, our starting value is going to be an array. And then what we're going to do is we're going to say array.isArray item, or specifically not an array. Then we're just going to return, and we're going to make this actually brackets. We're going to open this one up a little more. So we're going to say if array.isArray item equals false, then all we want to do is return our flattened list and the item. If the array.isArray item and the array.isArray item 0, then all we want to do is say, okay, return the flattened list that we currently have, but also return the item reduced to a flattened list itself. So what this is going to look like is we're going to say flatten, and then we're going to do item or nested list, and then we're simply going to say flatten and then the nested list. Just like that. But what we're going to have to do is then we're also going to have to separate that. Finally, if it's not just an item, and if it doesn't have a nested array, then we can just simply return the flattened and then the deconstructed item. Just like that. And unexpected string, where's that coming from? Forgot the comma. Just like that. Now we have an unexpected that thingamabob. And all types of typos. Flattened list. If, wow, my bad, guys. This is some ugly coding. And my mouse is dying. Oh no. Okay, there we go. There we go. So we have just taken a list of arrays that can go 3 arrays deep, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have properly flattened that list of arrays. And there's definitely a better way to do this, to like, I guess, loop through it and confirm, like, you don't have to care about how deep the list of arrays goes. But we just went a few deep, so we just added some quick ifs. All right, so now let's dive into some of the more powerful lessly used, but definitely more powerful examples we can use reduce for. So we're going to start off with a list of, here I'm going to need to reload it, and use a list of strings, and I think Google's got one. Yep, there it is. And let strings equal cool link hello world of, I don't know, JavaScript and goodbye. It's been swell. And then we're going to create an array of formatters. I would normally use filters here, but they're not really filters. They're just formatting the string. So these formatters are actually going to be callback functions. So we're going to be accept a string, and the first one is just going to be, okay, let's just say string replace, and we're actually going to use regex here, so we can globally replace underscores, or my bad, keybob, or whatever, I can't pronounce that, with spaces. Then we're going to say string is going to be capitalized, and so this is actually going to be string 0 dot to uppercase, and I do not like how hard it is to make things capitalized in JavaScript. And then we're just going to say the string after the first character. And so that's just a shortened way to concatenate that. But that just makes the string uppercase. And then finally, we're going to say if the string.length is greater than 10, then we're going to return string.slice 0 to 10. So we only want the first 0 to 10th character. And then we're going to say plus ... Otherwise, we're going to return the string. So those are our formatters. We have 3 formatters, and we have a list of strings. So let's do this. Our goal is to apply every single formatter on every single string. So we're going to say strings.reduce, and then we're going to say the list and then the given string. And then all we're going to say is, okay, first our initial value is going to be an array. Next, we want to return the list we currently have. We'll make that second, actually. And let's knock this to the next line. Just like that. And then what we want to do is we just want to do formatters dot reduce. And we want to format a string. And so we're going to say the accumulator, the value that is going to be returned every single iteration is going to be a string, and the item, the element from each iteration is going to be the formatter. And we're just going to call that format. And so what we're going to do is we're just going to format the string, and that's what we're going to return. Now here's the catch, is our initial value is going to be the string, and not the string from each iteration, or sorry, not the accumulator string. It's going to be the string from up here. So this string down here, or up there, is going to be the initial value for our formatters. And then, of course, we'll add a comma there. And so now if we run this, we just looped through all of our strings running a list of formatters. Pretty cool stuff right there. So then after that, let's clear this out and let's create an array of students. And this example, we are going to group the students by their class. Or I guess my grade school called it class. We'll call it room A. And then we'll just do this. And I'm going to copy this and possibly speed this along. So we want to group the students by their room. So what we're going to do is we're going to do students.reduce, and then we're going to say the accumulator is going to be the classroom or classrooms of the given student. Then what we're going to do is we're going to use these parentheses because we're returning an object. Every time we return an object directly, we need to use parentheses so JavaScript knows we're returning an object and not a function. It's an implicit return, I believe is what it's called. And then we're going to make our initial value, of course, the object, an empty object. And so all we're going to do is we're going to say, okay, first the student room is going to be our key. And then we're going to say if classes, or we'll just call this rooms. If rooms and then student.room already exists, return the room's student room, and then just pass in the student. Otherwise, just return the student. Okay. Yeah, that looks right. And then we're just going to simply deconstruct the rest of the rooms. So now, no, student, no. They're right. I hate it. They're right every time. I just want student, not students. There we go. So now we have the students grouped by, oh, we went wrong. Where did we go wrong? Student room with the student. We need to put this first. So when you deconstruct an object, you want to put it first. Otherwise, this will always override the pre-existing room. So that's where we went wrong. So because we were always overriding the rooms, it wasn't working. It was always taking the pre-existing student room. So by putting it this way, we're saying, okay, override the pre-existing student room with the current pre-existing student rooms plus the student, or if the pre-existing student room does not exist, then the room with just the student and not the pre-existing students. And so by doing that, we now have our students grouped by their classroom. Classroom A, classroom B, classroom C. Of course, if we go up here, Tim and Sally will be in A, and then Nick and Sarah will be in B, and Rick and Pam will be in C. And so that is how you group using reduce. So guys, that is about all I've got with reduce. I guess the biggest takeaways are it's a super method. It really is. It can do just about every other method that arrays are able to do. You can do just about anything with reduce, Instead of going like filter.map filter again, .map again, you can do that all within a single reduce method. Or maybe you go like for each .filter, and then you go within here, you take the array, and then you go .filter.map. Like instead of doing that, just create a reduce method. And honestly, like for each is the most overrated method I think there is in the JavaScript ecosystem. At least personally, that's how I feel. But yeah, guys, use reduce. Figure out like how to reduce using destructing and constructing and building up and combining. The last thing I guess I got is this. is if we have two objects and we did like name is clean code studio, and then we did like belief is simplify, and then we did one more and we're like should subscribe, and we say sí señor, and we'll just make that C. We can reduce this and combine all those objects. And so we're going to say the last example. And then we'll say partial. And then we'll just say last example with the given partial, right? And what is this going to return? It's going to merge all of the objects. And so it's so powerful. You can merge arrays, you can merge objects, you can filter, you can apply several filters, you can apply a list of callbacks, and I just highly recommend becoming extremely familiar, competent, and just able when it comes to reduce. It's amazing. And again, it's just an array, any types, reduce, and then the callback. And the callback has an accumulator, the given item for that iteration, and then optionally you can define the index and then the original array. Simple